Alright guys, the information with limits is given at the top of the page. I'm going to work through these examples with you. The simplest idea of limits is the limit as x approaches 5 of 3x plus 9. Simply plug 5 into x and work it out. 3 parentheses 5 parentheses plus 9. Work that out. We've got 24. There's our answer. Example number 2, same thing. The limit as x approaches 1 of x squared minus 5x plus 8. 1 squared minus 5 times 1 plus 8. 1 squared minus 5 times 1 plus 8. 1 minus 5 is negative 4 plus 8 is positive 4. Finished. Number 3, continuing with the the same basic idea. Plug 2 in. 2 squared minus 4 times 2 plus 1. 4 minus 8, negative 4, plus 1, negative 3. As we get to example number 4, we're going to run into a problem. If we attempt the same strategy, as x approaches 0, plug 0 into all of the x's, problem. Can never have 0 in the denominator. That 0 in the denominator makes this limit not exist. As we move to number 5, I think we're going to see a similar situation. As x approaches 0, plug 0 into the x's. Again, 0 in the denominator is our problem. Does not exist. We can abbreviate that DNE. If we're not careful, number 6, we may run into a similar problem. As x approaches negative 5, don't lose the negative. Negative 5 squared minus 25. Negative 5 minus 5. Negative 5 squared minus 25. 25 minus 25 over negative 10. We get a 0, but it's not in the denominator. 0 divided by negative 10 is perfectly fine. 0 divided by negative 10, 0. So with the idea of limits, sometimes they exist, we work them out, sometimes they do not exist. Sometimes it looks like they don't exist, but then they do. Example number 7 will illustrate that. If we plug 4 into the denominator, 4 minus 4 is 0, leads us to think this limit does not exist. However, let's factor the numerator and watch what happens. N squared minus 16. N squared minus 16 is your difference of squares. N plus 4, N minus 4. All over N minus 4. We should see that N minus 4s can now cancel out, leaving us with a new expression. The limit as N approaches 4 of N plus 4. Now when we plug 4 into the N, it'll work. 4 plus 4 equals 8. So initially looked like it did not exist. Using our prior knowledge to factor, now we determined that that limit does really exist. 8 and 9 is going to follow suit. With number 8, it's not the numerator we need to factor. X minus 2 can't be factored. But if we plug 2 into the denominator, 2 squared minus 9 times 2 plus 14 will give us 0. So we need to factor, this time, the denominator. So the numerator remains x minus 2. Factoring the denominator, what multiplies to give us 14 and add to give us negative 9 will be a negative 2 and a negative 7. So let me make that a negative 7. Now we see the x minus 2's to cancel out. We need to keep a 1 in the numerator to hold that position. So the limit as x approaches 2, 1 over x minus 7. Plug 2 into your x. 1 over 2 minus 7. 1 over negative 5. So that limit does now actually exist. Number 9 is going to follow the same way. With number 9, we need to factor the numerator and the denominator. So the numerator, again, your prior knowledge of factoring, positive 4 minus 1, x squared minus 1, x plus 1, x minus 1. And again, what we see they have in common that cancels out, x minus 1 and x minus 1 cancels. So the limit as x approaches 1 of x plus 4 over x plus 1. Plug in your 1. 1 plus 4 over 1 plus 1. That limit now equals 5 over 2. So first several problems, again, plug number in for x, work it out. If you get a 0 denominator and you can't factor anything like 4 and 5, limit does not exist. If you can factor it, then we need to factor, cancel out what they have in common, and then see if we can evaluate the limit. The last 3 will introduce a new technique for factoring that many of you have either not seen before or probably forgotten. And it's when we have the x cubed in number 10, x cubed in number 11, and x cubed in number 12. The numerator, x squared minus 4, we should be able to factor that as our difference of squares. X plus 2, x minus 2. The denominator, however, is a technique that I'm going to show you. Again, as I mentioned, you may not have seen before. If it's x to the third power and the number 8, think about cube roots. We're going to set up one set of parentheses as a binomial. A second set of parentheses will be a trinomial. The cube root of x to the third, x. The cube root of 8 is 2. That's going to start creating your binomial. The trinomial is derived from the binomial. So to create the trinomial, the first term is squared. So x becomes x squared. The middle term of your trinomial comes from putting those two together. So the x and the 2 creates 2x. The last term of your trinomial is when you square the second part. 2 squared becomes 4. So x cubed, cube root gives you your x. The number 8 cube root gives you the 2. And then from that binomial, the first part squared, x squared. Put them together, makes 2x. The second part squared is 4. The signs that we use comes from the acronym SOAP. The sign we use in the binomial is the same as the original problem. X cubed minus, so we use minus. The first sign in the trinomial is the opposite. Minus, so the opposite becomes plus. The last sign, AP, is always plus. Same, opposite, always plus. Same, opposite, always plus. That's the factor form of our denominator. X minus 2, x squared plus 2x plus 4. The x minus 2's now cancel, and we should be able to finish this limit. The limit as x approaches 2 of x plus 2 over x squared plus 2x plus 4. 2 plus 2. 2 squared plus 2 times 2 plus 4. 2 plus 2 is 4. 2 squared is 4. 2 times 2 is 4. Plus another 4. 4 plus 4 plus 4, 12. And then 4 over 12 reduces to 1 over 3. Number 11, again, the denominator x cubed plus 125 will be that same pattern that we just discussed on number 10. The numerator can factor to x and x plus 5. That's our GCF, taking the x out. The denominator, and set up one binomial and then one trinomial. The cube root of x is x. The cube root of 125 is 5. The first part squared, x squared. Put them together, 5x. The second part squared, 25. And then SOAP. X cubed plus the opposite of plus, minus, and always plus for the last one. X plus 5, x squared minus 5x plus 25. And again, the limit as x approaches negative 5. When we cross out what they have in common, the limit as x approaches negative 5 of x over x squared minus 5x plus 25. Careful with the negative. We'll plug negative 5 into all the x's. Negative 5 over, parentheses, negative 5 squared, minus 5 parentheses negative 5 plus 25. Negative 5 squared minus 5 parentheses negative 5 plus 25, 75. So negative 5 over 75 reduced down to negative 1 over 15. And then the last one, example number 12, the numerator factors, denominator factors, and it should still work for us. So the numerator, x minus 4, x plus 2. The denominator, I'm not going to work it out separately to the side on this one. X to the third cube root is x. The cube root of 64 is 4. The first one squared, x squared. Put them together gives us 4x. The second one squared gives us 16. So negative, same, negative, opposite, always plus. And now we have the x minus 4's canceling out. So the limit as x approaches 4 of x plus 2 over x squared plus 4x plus 16. 4 plus 2 over 4 squared plus 4 times 4 plus 16. 6 over 16, 16, and 16, 48. Reduces to 1 over 8. Thank you.